Hi, welcome everyone. Welcome to section 1.6. So today what we're going to be doing is going over transformations of graphs. And so what we're trying to do is being able to recognize basic functions. And we went over some of these already um, on the first sections of this course. So we begin by looking at our linear function, which has a slope of m, and so where m is your slope and your b is your y-intercept, okay? And this means that we have an upward slope. Here is going positive, so we know that m is a positive number. We have a constant function, y equal b. This is a horizontal line because we do not, our slope is 0, m is equal to 0. So we have a horizontal line. We have the identity function, meaning that it's y equal x, that they're both the same. Both x and y are the same. So 1, 1, 2, 2, 3, 3. 0, 0, 1, 1, 2, 2, 3, 3. So the values of x and y are the same. That's what it's called, the identity function, but it's also a line with a slope of 1. So see how rise up, rise and run, rise 1, it's always 1. So the identity function, your slope is 1, and your points are symmetrical, 1, 1, 2, 2, 3, 3, 4, 4, and so on. We have the absolute value function that looks like a V. And why does it look like a V? Because we know that this is always going to be positive. Y, the Y value, is always going to be greater than 0. That's why it's above the x-axis. We have our quadratic function that looks like a U shape. And this is also always greater than 0. Y is always going to be greater than 0. Positive or negative squared to give me a positive number. So that's why your behavior looks like this. You have a cubic function where we know that the domain and the range are both negative and positive infinity. Okay, we have the square root function that looks like an arrow. It's greater than 0. We're not going to have any values to the left because we're not allowed to have any negatives inside of root. So it's always going to be living in the first quadrant. And then here we have the cube root function that looks like an S. Like so. Okay. So then here, the Y values are being restricted. And then lastly is the reciprocal function that we know that here there's going to be a gap because of course 1 over 0. So x cannot equal 0. You're not allowed because then that would make my function undefined at that place. Okay, so these are just recognizing how they look of the transformation. So we're going to be using these basic functions, or I like to call them mama functions, because mama has children and those children are going to be the transformation. So that's what I like to call them. These are mama functions. These are functions that, those are your basic functions that are the we like to start at the origin, sometimes if we can, with no transformation. Now, the first thing that we want to be doing with these mama functions is applying transformations. So one of the first transformations we do are called shifting. We're going to be doing vertical shifts, and we're going to do horizontal shifts. So what's the difference between the two? When you have a vertical shift, you're going to add a plus or a minus c to mama. So assuming that f of x is your mama function, your basic function, when you add a plus c, let me get rid of that. When you add a plus c, that means you're moving upward, but make sure that it's it has to be outside. The vertical shifts happens outside of the function. So see how there's f of x and then plus c on the outside of x. And then of course, if it's a minus c, then you're going to move downward. It's outside a function. Now what happens if you have a horizontal shift? Now it's going to occur. This h is a horizontal shift to the left. H units. And then notice how it's on the inside. The h is on the inside of the function. And then of course, f of x minus h. You move h units to the right side. Let me fix that. Okay. So these are called horizontal and vertical shifts. So let's go ahead and get started on one example. So we begin by having the original mama function, and these are the families. So notice that this plus 2 is on the outside of the function. So this would mean a vertical shift. And this plus 2 is on the inside. So then this would be a horizontal shift. Let's begin by identifying what type of shifting we're going to have. Notice we have the square root of x plus 2 on the outside. That's a vertical shift upward 2 units. This one is going to be to the left 2 units because this is a plus 2. So if we recall by definition, if we have a plus h, this case is a plus 2, we're going to go to the left. H units, so 2 units to the left. So what we're going to be doing is that we're going to be graphing both of these functions simultaneously and then be able to identify what's going on with the graph. So the first thing that I'm going to do is I'm going to evaluate my function. I'm going to start with the parent function, and I'm going to do, okay, well, what's the square root of 0? That's 0. The square root of 1 is 1. The square root of 2 is irrational. I don't know what it is, but we can approximate it. And then we have the square root of 2, which can be also approximated, and the square root of 4 is equal to 2. We know that. So the square root of 2 and the square root of 3 are very close to 1.4. This one's roughly 1.4, 1.7-ish. So using your calculator, you can determine. Now what happens if I add a plus 2 on the outside? So this is a 0 plus 2. This is 1 plus 2. So we're using mama. This one is 1.4 plus 2, which is 3.4. 1.7 plus 2 is 3.7. And then 2 plus 2 is a 4. Where am I getting these numbers from? I'm getting them from mama. See how 0, 1, 1.4, that's exactly what I'm using there. Now what happens if I add it on the inside? So that's going to reflect something different. So I'm going to use the square root, excuse me. I may change that orientation for a moment. And that's going to be the square root of 0 plus 2 on the inside. That's the square root of 2. The square root of 1 plus 2, that's the square root of 3. The square root of 2 plus 2 is, and I'm adding a plus 2 because that's what my function is telling me to do. That's the square root of 4, which is equal to 2. We have the square root of 3 plus 2 on the inside. That's the square root of 5. And then the square root of 3 plus, sorry, this is 3 plus 2, and then this is 4 plus 2. And then on the inside, and that's the square root of 6, which is going to be approximated. So we know that the square root is roughly 1.4. We know roughly this is 1.7. We know that the square root of 4 is 2. The square root of 5 is roughly 2.2, and the square root of 6 is roughly 2.4. So what we're going to be doing is graphing. I'm going to graph both my parent functions on both of these. And then here I'm going to do the vertical shift. So the square root of x plus 2. And then on this side, I'm going to do the horizontal shift, which is the square root of x plus 2 on the inside. All right. So let's begin by doing mama function. The parent function will be the orange. So 0, 0. Now here would be 0, 0. My point 0, 0, 1, 1. I have 2, 1.4. I have 3, 1.7. And then I have 4 and 2. Like so. So I'm going to draw my line. Like that. Same thing here. 0, 0, 1, 1, 2, 1.3, 1.7, and then 2. Like so. Let me change that one. Oh, back. It looks like an arrow like so. That's mama. Now what happens when I use the green, which is the vertical shift? Now that's going to be 0, 2. Excuse me. It's going to be 0, 2. And this should be the square root. I'm going to have, we'll go back. So 0, 2, 0, 2, right here. 1, 3, 1, 3. So 1, 3, 2, 3.4, 3, 3.7. Let me fix that. 3.7, and then 4 and 4. And this one's a little slightly off. Like so. So notice that it moved 2 units up from the point. So it vertically shifted 2 units up. Okay. So from each point, it went up 2 units. Now this one, we're saying we want to know it's horizontally moving. So then for this one, the blue, it's 0 and 1.4. So we have 0 and 1.4. So my x is 0 and my y value is 1.4, like right here. And then I have 1 and 1.7. And then we have 2 and 2. And then we have 3 and 2.2. And then we have 4 and 2.4. So what happens? So what happens if I pick x to be -1? So it's going to be the square root of -1 plus 2, which is the square root of 1, which is 1. So -1, 1. If I pick x to be -2, it's the square root of -2 plus 2, which is the square root of 0, which is 0. So like this. So sometimes, in order for you to see the picture, so notice how it shifted to the left. 2 units. And we were able to see that because we substituted a -1 and a -2. So sometimes you're going to have to substitute more than what just they give you in order for you to see the big picture. And that's happened because there's a +2. So we know that x can be up to -2. It can't go to -3 because then this will become negative and we're not allowed to have any negatives. Okay. Okay, so then we have the next one. And this time our function that we're working with is a u, right? Because we have so my mama, the basic function is a quadratic that looks like a U shape. So let's start by defining these little things. So when we start plugging in 0 squared, I get 0, 1 squared. We're doing a substitution is 1, 2 squared is 4, 3 squared is 9. And then of course, 4 squared is equal to 16. Now what happens if we have, now notice it's a vertical shift because it's on the outside, a -2. So all we have to do is carry it over, 0 minus 2, -2, 1 minus 2, we're using the answers. 1 minus 2, it's a -1. 2 minus 2, oh sorry, 4 minus 2, because we're using 4 squared. 1 second. So what are we plugging in? 0, 1, 4, 9, 16, we're using that. So 4 minus 2, we get 6. 9 minus 2, we get 7. And then 16 minus 2, we get 14. Now, the only difference is that this one is a horizontal shift. So x minus 2, that would be 0 minus 2 squared, is going to be a +4 because 0 minus 2 is a -2. -2 squared is a 4. 1 minus 2 squared is going to be a -1 squared, which is a 1. And then we have 2 minus 2 squared is a 0. And then here we have 3 minus 2 is going to be squared is going to be also 1. 3 minus 2 is 1. 1 squared is 1. And then 4 minus 2 is 2. Squared is 4. So then 0 minus 2 is a -2. Squared is a +4. So now that we've substituted and evaluated my functions, we can go ahead and again, I'm going to draw mama. So mama was 0, 0, 1, 1, 2, 4, 2, 3, 4, yep. And then we had and then 16 all the way up here. So assuming this is 16, and we know that there's a U shape that's symmetrical. This is because of symmetry. So we were only given a few parts, but this, sorry, the green, what am I doing to the green? I'm adding them because I know that they're symmetrical. We know that this is going to be a U shape. And I'm a terrible drawer, you're going to be able to identify that. So this is mama. Now what happens when I do a vertical shift? That means now I'm at 0, -2, 1, -1, 2, 6, 3, 7, 4, and 14. So then it's 0, -2 down here. 1, -1, 2, 6. So at 2, sorry, this should be 6. This should be 2. So at 2, 2. And then I have 3, 7. and then 4 and 14. So then we know that this is going to go like so. Let me fix that. That looks weird. Like that. So this one went down, a vertical shift downward by 2 units. So notice how this went down 2 units, down 2 units, down 2 units, like so. And then very similarly, we're going to do mama function 3, 9, and then 4, 16. So we're also graphing mama function on the other side. The blue is mama. Now I'm going to do the horizontal shift of, I have 0 and 4. So 0, 4. And then it's 1, 1. And then it's 2, 0. And then we have 3, 1. And then we have 4, 4. So this, it's gonna go like this. So this is, we know that this is a horizontal shift to the right 2 units. So notice how this moved to the right 2 units. Each of them moved, each point moved to the right for, 2 units. So we know that because there's a -2 on the inside, so we know it's 2 units to the right, and this one's 2 units down. Now, what if we want to recognize the type of shifting? Well, if we notice here, we have z of x to be equal to an x plus 1 squared minus 4. We notice that there's a subtraction on the outside. This means this is a vertical shift down 4 units from mama function from the original. What is the original function? What is mama? Mama is x squared because you have a quadratic right there, and you have a horizontal shift, and this is going to go to the left 1 unit. So then if we graph the original function mama, 1, 1, 2, 4, the orange is mama function, the original. Now without having to do a table, we know that the inside is left 1 unit, down 4. So from this point, I'm going to go left 1 point and then down 4. So I'm going to go left 1 unit and then 1, 2, 3, 4 right there. And then I'm just going to draw a parabola right there. So left 4, left 1, left 1, down 4. Now my new point is going to be right there. My new starting point will be on that parabola. And you can verify that using Desmos. And we're going to do one more. So then for the next one, the horizontal shift, we know that the mama, the absolute value, is mama is the absolute value of x, and that looks like a v. That's what we learned in the morning right now. Now, what about the horizontal shift? Well, we know this is x minus h plus k. This h, this horizontal shift, it's a minus, so we know that's going to be to the right 2 units. And then K, the plus, it's addition, so it's going to move upward 3 units. Because of the outside, we learned that that's a vertical shift. So if we draw mama, I'm going to draw mama. So 1, 1, negative 1, 1, 2, 2. So we know that mama is going to look like a V. That's mama. Now what happens if we move mama to the right 1, 2 units and then up 1, 2, 3? That's going to be my new starting point. And then my graph will move towards that side. So again, 2 units to the right and then up 3. To the right, 2, and then up. It's always horizontal first. Always horizontal, then vertical. See how up here we did left first, left, and then down. So it's always horizontal first. Okay, and that's how our graph looks like. Again, Desmos will be your best friend to be able to modify and see the graph. So you're going to be doing the Desmos activity that involves shifting, of course. And then so you can play around with the Desmos activities and be able to see all these transformations that's going around, and that in terms of vertical and horizontal shifting. Now, what happens if we apply vertical and horizontal shifting and stretching? So shrinking, what does it mean to be shrinking and stretching? So that is actually depends on the coefficient, the leading coefficient in front of the function. So notice we have a f of x, and then this one's again on the outside, and this is on the inside. So you're going to have a vertical shrink or stretch when the a is on the outside. And you're going to have a horizontal shrink or stretch when it's the a is in the inside. So what is the differences? So we're going to be able to see that. So for example, number 5, 1/4, and the 4, they're both on the outside. So they're going to be vertical shrinks or stretches. And then number 6, because the 5 is on the inside and the 1/5 is on the inside, we're going to have horizontal stretches. So just identifying that. So see how this is the original f, and then the 4 of x is going to do something to these values because the 4 is on the inside. We know it's going to be a horizontal type of stretch. Okay, so just identifying what we're going to be doing is very important. So as of now, we're going to start working on this problems.